Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. A census counted the total population of males and females in a town to be 300,000. If there were 1,500 more females than males, what percentage of the population were females? This is actually a pretty simple question, belonging to the topic of percentage. And this type of questions are fairly common in standardized tests. And this is not very difficult, but the trick here really is to figure out a way that will be, quick, easy, and time efficient, which is especially important for time tests. So there are really two ways to solve this. One is the more traditional way, and I'll show that first. And that takes actually a little bit longer. And at the end of it, I will basically show you what will be a way more time efficient method to get at the solution, especially given the fact that this is a multiple choice question. So let's start with the traditional method, which most of you will be very familiar. So the thing to do here is to just, let the number of females be some unknown variable f. We know that the number of males will be equal to f minus 1,500 because there are 1,500 more females than males. That means that there were 1,500 less females than whatever the number of females were. So the number of males will be f minus 1,500. And we know that these two should add up to the total population of 300,000. So the equation that we can write is f plus f minus 1,500 is equal to 300,000. And from this, we have essentially 2f. And then we take the minus 1,500 over to the right-hand side, so it becomes plus 1,500. So on the right-hand side, we have 300,000 plus 1,500, which comes to 301500. And then we can find f by dividing this by 2. It's a pretty large number. So here I have to do some math, and we come with this answer 150750. So this is the number of females. This is still not the final answer because we are asked about the percentage of the population, right? So this is just the number of females. So to obtain the percentage, we divide this by 300,000 and then multiply by 100. And these are, again, like I said, fairly large numbers involving 6 digits. So if you do all the math right, this is the final answer that we'll be getting, which is 50.25. So this is one way of doing the problem, and as you saw, this is a more traditional way, but in this particular case, it involved dealing with fairly large numbers, doing some, math, some division, addition, etc., with numbers that are fairly large. And those of you who are not the most comfortable dealing with math involving very large numbers, especially if you don't have a calculator handy, this can be, somewhat time-consuming as well as intimidating. And there's always the chance that you can make some silly mistake, which may not give you the correct answer straight away. So what's an easier way to solve this? So there is actually a very easy almost one-step solution to this problem, which I'm going to show next. And this is going to be way more time efficient. So what does that solution look like? Well, we start with the fact that the number of females exceeded number of males by 1,500. So that's given in the problem, right? But we can ask the question, this exceed of 1,500, what is it in terms of percentage of the total population? So we know the total population is 300,000. So if we express 1500 as a percentage of the total population, that would be simply 1500 divided by 300,000 multiplied by 100. And again, the numbers here are large, but they are way easier from the perspective of doing the math because there's a lot of zeros. So we can actually, cancel out the zeros from the numerator and the denominator. We have 2 zeros that will cancel out, and then 100 has also got 2 zeros, so we can cancel out 2 more zeros, and we are basically left with this 15 by 30. And what is 15 by 30? Well, it's half, right? And half expressed as a decimal would be simply 0.5. So this comes to 0.5 percentage. So we know that females will exceed males by 0.5%. So whatever the percentage of female is, that will be greater than the percentage of males by 0.5%. And one thing we can do from here on is, because we have been given these options, we can directly check against the options. So we have been provided the percentage of females in the options. So if we subtract that from 100, right, we'll get the percentage of males, and then our job will be to check which option provides a difference of 0.5%. So let's do that. If we subtract 100, if we subtract 50.05 from 100, we get 49.95 as the potential percentage for the males from the option A. And we can do the same thing for the rest of the options. So these are the percentages of males. And then we simply check which option provides a difference of 0.5 percentage between males and females. And if you do a quick check, it's pretty easy to see that it's option B which provides that difference. So the correct choice in this case will be simply option B. So this is a much time efficient method without you having to do math involving really large numbers. So this is a trick I wanted to show so that you are aware. If you get a problem like this in your timed standardized test, you can apply this and solve this problem way more quickly than the traditional method.